We started OSPF in the previous class and we learned few important points about OSPF. Open shortest path first uses SPF algorithm. Shortest path first algorithm is used in this routing protocol. Shortest path first is just an algorithm, but OSPF is a routing protocol. They are not same. Shortest path first is designed, proposed by Dijkstra. But routing protocol SPF is an RFC. No one is proprietary. No one take ownership. It's open standard. Open shortest path first. That's why the name open. It's open for everyone to run in the router. That's why every vendor supports OSPF. In Cisco for OSPF, the preference level, the trust level, which is called as administrative distance, is 110. OSPF comes under link state routing protocol. OSPF supports unlimited hop count. To accommodate a very large scale network, areas, two level of hierarchy. Area 0 as a backbone. Rest of all the other areas connects to area 0. Only then they can talk each other. Without area 0, no two areas can communicate. The advantage of areas we saw in this page. Minimize the size of the routing table. When the size of the routing table is minimized, the CPU utilized will be less. The time taken to find the exit interface will be less. And when a small subnet goes down, the flooding happens only within that area. The detailed LSA flooding stops at the area boundary. So this two-tier architecture, the hierarchical design is good. Only with the help of this, we get the boundaries. Only when you have boundaries, we will have summarization point. Can anyone tell me in this topology, where is the summarization point? I'm just checking how much you understood. Correct. CDE or the summarization point. C is the summarization point for area 1. E is the summarization point for area 3. Now we are here. OSPF will not share route information in the hello packets. Hello packets are simply to say hello. With the hello, what is the benefit? When the neighbor router says hello, I learn about neighbor. My router learns about neighbor. When my router say hello, my neighbor router learns hello. My neighbor router learns about my router. Just to discover the neighbor, the hellos are exchanged. Neighbor discovery only. There is nothing more than that, you see. So hellos will not make the routers to synchronize the database. Hellos are just to know the names, router IDs, and their area, and their timers, etc. The hello packets carry a lot of things. Among them, few parameters must match in order to form neighbor. C and E cannot just simply form neighbor by only sending router ID in the hello packet. They not only send the router ID, they send an area ID. They also send timers, the dead time. They also send the subnet in which they are, and much more. So when hellos are exchanged, the routers will look for certain parameter. If only the parameters are matched, the neighborship comes up. If C is in one area, E is in another area, the neighborship will not come. Hellos will be kept sending between these two routers, but they don't accept as neighbor. So certain parameters should match in order to form neighbor. We will see in detail what all goes inside hello packets later. As of now, what we learn is two routers learn each other, their existence using the hello packet. Not only that, after forming neighbor, they share the updates, they exchange the updates, they get fully synchronized. As I said earlier, the database will be identical within an area. Any router you check the database of the OSPF, it will be same. After they form fully synchronized identical database, the hello packets are kept on sending in order to maintain neighbor. How often? As I said earlier in the previous class, this is the time. Even after forming neighbor, after learning each other, after getting fully adjacent, even after that, the routers send the hello packet every 10 seconds. That is to maintain neighbor. Okay. Now forming OSPF adjacency. You see, forming neighbor in point to point and in a broadcast environment are not same. LAN links are called as broadcast type. Broadcast. That's the link type. Wherever you use Ethernet, Ethernet, we call it as LAN links. LAN links are broadcast domain, broadcast. Link type is broadcast. Wherever you have serial, serial, which is point to point link. WAN link is point-to-point link. LAN link is broadcast Ethernet link. When you have serial link between two routers, they form full adjacency, full. Meaning this R1 and R2, they form full adjacency, meaning R1 will give everything it has got to router 2. And router 2 will also send everything that it has got to router 1. Full adjacency, that is the meaning of full adjacency. R1 and R2 forms full adjacency. They share everything. Whereas in an Ethernet environment, because you have Ethernet wire, you may be having multiple routers connecting to a LAN switch. You cannot connect to a LAN switch using serial wire. Serial wire is P to P, point to point only. Only two routers can be connected to a WAN wire, serial wire. Whereas using a LAN wire, you can connect multiple routers because you got a LAN switch for Ethernet. In this environment, full adjacency will be formed only with DR and BDR, and two-way relationship will be formed with other routers. What does that mean? Full adjacency with the DR, BDR, two-way neighborship with other routers. We call it as DR other, designated other. So what is DR? Designated router. Designated router. This is backup designated router. Designated router, backup designated router. This designated router and backup designated router is like, if I need to say a very good example, it's like a very good family. Husband, wife, child 1, child 2, child 3, child 4. Now, all children will update both the parents. Usually, when my younger one get hurt, she'll first come and cry to me. After that, she will go and cry to mother. Sometimes she will go and cry, Akka, Akka, she will cry. So she wants Akka also to pacify her. When she falls down, everyone should pacify her. So children, they share everything to father and mother. Due to space, I just take 3 children. So this husband is what I called as DR, designated router. His wife is what I called as BDR, backup designated router. And children is what I call it as designated others. In future, they're also going to be one father and mother, but as of now, they're children. Designated other. You see, this designated other, they don't really share everything. They love each other a lot, but these children, when we buy something, when they choose something, Not all children I'm talking about. My younger one is different from elder one. So they don't share sometimes. They will be ready to share with the daddy and mommy, but not to sister. You know. So what I'm trying to say is the C1, C2, C3, they don't have full adjacency. They don't have full adjacency. But they have full adjacency with father and mother. But child 1 knows that child 2 and child 3 are my sibling, my sisters. Child 2 knows that child 1 and child 3 is my sister. They know that we are sisters. But they don't share anything with them. They don't share. Just for example, not every children, my children are very sweet. Very rarely they don't share. Now, just for understanding this DR, BDR, DR other, I'm telling. These children, they share everything with father and mother. So if this child has got an yellow color pen, and if child 3 wants it, father will go to child 1 and say, okay, just for one day you share with your C3. Then okay, for father, sister, the daughter will give, and father will give to this child. That is how the route is also distributed. Child 1 don't advertise anything directly to child 3. The DR other, it forms neighbor, no doubt, it forms neighbor. But they don't share any updates. Then how will C1 update be learned in C3? Through father, through the designated router. Through designated router. Only through DR they learn. Then why do we need backup designated router? Backup designated router is in the absence of DR. When DR goes down, someone should lead. Someone who knows C1, C2, C3, someone who knows the DR other 1, DR other 2, DR other 3. Someone who knows DR other 1, who knows? Only DR knows DR other 1, DR other 2, DR other 3. Only DR knows, not only that, parallelly BDR is also updated. I told you every children will have full adjacency with both parents. So now, whatever DR knows, BDR also knows, but only DR is an active responder. BDR will not respond. BDR will simply collect all the route informations from DR other 1, DR other 2, DR other 3. Whatever DR knows, BDR also knows. But when there is a query from DR other 2, the query will be responded only by DR, not by BDR, not by BDR. BDR is only, as I said, backup designated router. See, I want to repeat again, this is a LAN environment. We are talking about this, connecting routers through switch. Among this 5 router, 1 router is elected as designated router. Another one is backup designated router. And the rest all will go into DR other. Except these two routers, all other routers are called as DR other routers. And these two routers are called as DRs. Sometime in some documents you will see DRs. It means both DR and BDR. Parents. Parents mean both father and mother. DRs means DR and BDR. Fine. We have DR now. How it became DR? That is what we need to know now. Out of this 5 router, why that router has become DR? In the previous page, we saw hello packets. In the hello packet, one important parameter called priority. Priority is sent. The default priority on all the LAN links, Ethernet links, on all the LAN link, the default priority is 1. When we increase the priority bigger than the default, that router becomes DR. So here, this router is a DR router because of high priority. The maximum priority you can give is 255. The default priority is 1 on all the routers. To make it DR, I can set priority on this port. I can set priority 255 so that it becomes DR. And on this port, I set maybe 100 so that this will become BDR. And all the rest are having priority 1. The one with the highest priority becomes DR. So when all these routers, I repeat, when all these routers boot, they all come online at the same time and they start sending hello packet. The hello packets helps to compare their priority. The router with 255 priority will say, no one else have got this big priority, so I am promoting myself. I am BDR. Yes, I did not say DR. It will say I am BDR. That is what first it will say. After some time, it will say, since no one objected, I understand I'm the only one who has got the highest priority. So I am promoting myself from BDR to DR. So what I said is, by default, straight away it will not become DR. First it will be BDR for a few seconds. When no one objects, then it will say, I will be a DR because no one has got 255 priority. This guy says I am having 100 priority, others are having priority 1. This is how it goes from one state to another. And the second router has become BDR and all the rest has gone to DR other state. Now, the DR others form full adjacency with DRs, meaning between these and between these, no full adjacency. They are only neighbors. Full adjacency is only between this. See, routing updates and topology informations are passed only between routers that are fully adjacent. So only between these two routers you will have LSDB synchronized, not between these two. Synchronization is happening only with DR and BDR, and also between these two. These two also get synchronized. This all get synchronized. What I'm trying to say is between these two, it is only neighborship. It's only neighborship. Neighborship is not fully adjacent. Neighborship is, I know you, you know me. That's it. Full adjacency is knowing everything. Fully synchronized database. Just knowing the router ID of the neighbor router is neighborship. Not just the router ID, you also have the complete database of that router in you and your router in that. That means full adjacency. Adjacency is only between the device that I've got means topology informations and routing updates are passed only between the routers that have got full adjacency. Once the adjacency is formed, the synchronization all finish, they form full state. So what did you learn from this page? From this page you see in a point-to-point network, there is only two routers. Because it is serial wire, there cannot be third router. So they got full adjacency. They got full adjacency, no secrets. Whatever R1 knows, R2 also knows. Whatever R2 knows, are full adjacency. But in an Ethernet environment, you may have many routers. So what happens, in each LAN, there is going to be one DR and one BDR. Only with the DRs, all DR other routers form full adjacency. Between the DR others, they don't form full adjacency. They will stop in a place called two-way state. It is coming in the next page. Two-way state is like this. You meet someone in the airport because you were there for around 3 hours for the next flight, connection flight. He comes and introduces himself. I am Jeremy. I'm from Germany. And I said, hi, I'm from India. I'm Jay. That's all. Maximum what you will do, what you will talk, what do you do for a living. That much only. Not more than that. நீங்க எவ்வளவு சென்ட் இடம் வச்சிருக்கீங்க, அதுல என்ன போட்டிருக்கீங்க, மழை வந்துச்சா? No. I don't think we will talk those things in an airport with a German friend. That is called two-way state relationship. Two-way means he knows my name and I know him. Yeah, he's from Germany. He is doing so-and-so work. Likewise, he also knows me. That's all. If you ask me how many children he has got, I do not know that. I don't know the information. I don't know. Because we did not have full adjacency, we had only two-way. So with these routers, it is only two-way states. But between these, it's full adjacency, full with this. And the election happens in the beginning by comparing the priority in the hello packet. But what if I did not set priority? The default is 1. If all have the same priority, then which router will become BDR? The router with router ID. We all learned this in CCNA. What is router ID? Every router will have a unique 32-bit address called router ID. That router ID can be manually given. If you don't give it, will take from the loopback interface. If there is no loopback interface, then it will take from the physical interface. The biggest IP address only it will take. So every router has got a unique router ID. In the hello packet, router ID will also go, not only priority. I told you in the hello package, there are a lot of things shared. Few things should not match, few things should match to form neighbor. If two routers have got the same router ID, they won't form neighbor. They won't form neighbor. If two routers have got same area ID, they will form neighbor. But if they have same router ID, problem. Confusion, no? When I was in 4th standard, I was studying in a place called Chengalpattu, Seventh-day Adventist school. In my class, there were two guys looking very similar, twins, Raman and Lakshmanan, who were running, his father was running a bakery called GK Bakery, close to that old bus stand police station. Confusion because of the same identical face. One likes me, other one don't like me. I don't know who like me and who hate me. How will I talk? It was confusion. Likewise, if two routers have got same router ID, then the routers will be in confusion who gives this update, whether that or this. So router ID should be unique. Now, if you don't set priority, the default priority is 1, then there is a tie. So the decision will be made using the router ID. The router with the bigger IP address as the router ID becomes DR. The router with the second biggest router ID becomes a BDR. Right, this is how the election happens. Anyone has got any question on this page or on the previous page? Hello packets are sent to multicast address. Both in LAN and WAN, it is sent to 224.0.0.224.0.0.5. So this will be sent over the wire, whether it is WAN wire or LAN wire. Depends on what all networks you advertise. All those interfaces where you run OSPF, they are going to send the hello packet to this address. On the other side, if the receiver is also running OSPF, only then it can open it and process it. If the receiving router don't have OSPF, then it will not be able to open the packet. Only the router that runs OSPF will join this 224.0.0.5. See, we'll be learning later a topic called multicasting. There you will know how these routers use multicast address to communicate. So question was, will the hello packet be sent on all the links? No, it depends on what all the links that you have enabled OSPF. Only on those links it will be sent. Again, on the other side of the link, if the router runs OSPF in the same area, then it is going to receive it and process it and form neighbor. If if the other end of the wire don't have OSPF, it may receive the packet, but it cannot open it and process it. Any other question? Now, we learned that LSAs are sent between neighbors. I repeat, LSAs are sent only after forming adjacency, full adjacency. It will not be sent between others, dear other routers. It will be sent only with the router which has got full adjacency. And the LSAs forms LSDB, link state database. And this link state database will be identical within the area. So now imagine we are all in Chennai. Imagine you are all in Chennai. And you all are new to Chennai. Assume, imagine, assume. We are all new to Chennai. And I am in one corner of Chennai, you are all in another corner. No one is in same area, okay? Each one of you are in different part of Chennai. All landed today morning only. We are all friends. We discussed that we will meet in Chennai. So you all landed in Chennai, in different corner of Chennai. Now, our aim is to come and meet in a place called, let's say, Phoenix Mall in Chennai. We want to meet in Phoenix Mall. So what do you all do? What we all do? We take a map. We all have a map. We open our map. First thing is we see where we are in that map, isn't it? I will locate myself in the place where I am in Chennai. You will not locate yourself in my place. You are in different part of Chennai. You will locate yourself in that place where you are. So every one of us have a common map. That's what this first point is. We all are in same area called Chennai, and we all have one map called Chennai map, identical database. But we place ourselves in the different portion of the map. That is the root place. That is the place from where we are going to start. Where you're going to the destination, Phoenix Mall, specific destination. Let's say I am in Tambaram. I position the map myself in Tambaram. You position in Ainavaram, and he position in Annanagar, and she positions in Velacheri, and he positions in Tinagar, Usman Road. And we are all going to meet in a place called Phoenix Mall. Here. So I position myself and I see with my eyes the route, this route. That will not be your route. You position yourself here and see this route is better for you. You see this route is better for you. You see this route is better for you. There is no other route. There is another route like this. So you pick this route. I pick this route. So everyone position ourselves in the map and find the shortest path for ourselves. Likewise, though every router have got a common map, the best path is calculated with respect to the low cost path link to the specific destination from this route from where we are routed. And then the best route is kept into the routing table. To calculate the shortest path first, the low cost path, for that only we use SPF. So in an area, every router will have a common map. To go to a destination, not all routers are going to have the same route because in the map, each router is in different part of the map. They need to find their own best path. Only by LSAs and sharing of DBD, map can be learned. But designing the best route is done by each router by using SPF algorithm on this map. What is the name of the map? Link state database. Like this. You see, every router have got a common map called link state database, and this is the database. If I am X and if I want to go to F, there are many ways. I can go like this, 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 I can also go like this, I can also go like this, I can also go like this. But I don't do like that because I'm going to pick the shortest path. For this router going like this, let's say each link is cost of 10. Each link is 10. 10 plus 10 plus 10 is 30 this way. 10 plus 10, this is just 20. I take this path. 10 plus 10. This is 10. This is another 10. You see? So these through lines are elected paths. The dotted lines are not elected. This electing the path is using binary tree algorithm called Dijkstra's SPF algorithm. How many of you understood this? So far, everyone good? Okay. I'm going to leave this page for a minute, go through this page, and I'm going to explain after a minute. You see, a router. A router is receiving LSU. I told you LSU is nothing but collection of LSAs. So when an LSU comes, it will come with a sequence number. We'll talk about sequence number in the next chapter in detail, but it comes with a number, like a version number. Now, first, this router is checking whether my database is it having something in it or it is empty. If it is empty, nothing in database. So whatever come in, just add it to the database. Just add it. Because your router is fresh, just started. And it formed a neighbor with the next router. Next router is there for 5 years. That router has got a lot of topology information. This router is just coming up. Okay. This router comes up and then gets the updates called DBD or LSU. Because it's first time, the local database will be empty. So whatever, when there is nothing in the database, you just add whatever comes into the database and send the acknowledgement to your neighbor who sent you. Whoever sent you this, you send thanks message, acknowledgement, and then for your neighbor, you can flood it. You will also have a neighbor, no? This is your router, and there is one big route network. You just got updates from this guy. You send the thanks message, acknowledgement, and then now you start flooding it to your downstream if you have, and then start calculating and get the new routes. Now you will be visible for these networks. After this conversation, this router can now ping these networks. Calculate. We just learned how to calculate in the previous page. Shortest path first, low cost path. Put it into the routing table. So if anyone pings, the packet will go there. This is when the router is fresh. The next scenario is the router is not fresh. It is not empty. It has got already something. It has got something in the database. Now an update is coming, LSU is coming. Do you have anything in your database? Yes, I have. Is the database sequence number and incoming sequence number is same? No, it is not same. If it is not same, is the incoming is higher or lower? Incoming is higher. Higher means you need to add to the database. This is this one. Add to the database, send the acknowledgement, flood it, blah, blah. You know this. If the sequence number is same, this is also 3, you also have 3, which means you already have updated one. Ignore it. If the sequence number that you have is higher than the incoming one, what does that mean? You have a latest one. This guy who is sending is old guy, old update. You have a latest update. So you do one thing, you send the newer information back to this guy with the sequence number 4. That's it. Go through yourself, please. The last point, let me repeat again. Update is coming to a router. The router checks whether my database is empty or having some info. It is already having some info. Okay. Is the database sequence number same? Yes. Then no need to update your database because whatever comes in, you already got because the sequence number is same. What if it is not same? It should be higher or lower. If the incoming is higher, if the incoming, let's say this update has got sequence number 5, and in your database, your sequence number is 4. Is the sequence number higher? Incoming one? Yes, higher. Which means you need to update your database. So go to A. A is here. What does A say? Add to the database, send the acknowledgement, flood it to the neighbor, recalculate. This part you understood? Now, if the sequence number is, sequence number will become 5. Now, next assumption. Next assumption is the incoming sequence number is lower. You already have higher. Okay. So there are many neighbors, right? One neighbor gave you the latest one. The other neighbor is giving you the old one. You understand? When the lower sequence number update comes, which means your friend is not updated, you need to update. So you send your LSU with the newer information to the friend who sent you with a lower sequence number so that he will be updated. You tell him what you send is lower. What I have is better one. Take mine. Yeah. Update the sender itself. Did you understand this point now? The red one? Mm. See, incoming lower. Incoming is lower. அனுப்புறவன் பழைய அப்டேட் அனுப்புறான். ஆனா நீங்களோ லேட்டஸ்ட் அப்டேட் வச்சிருக்கிறீங்க. அப்ப என்ன பண்ணும், அனுப்புறவனுக்கு அட்வைஸ் பண்ணும், பார்ப்பா நான் லேட்டஸ்டா இன்னொருத்தங்கிட்ட இருந்து வாங்கினேன், அது நீ கொடுக்கறத விட லேட்டஸ்டா இருக்குது, இந்த நீ நான் கொடுக்கறத வச்சுக்கோ அப்படின்னு சொல்லி சோர்ஸுக்கு நம்ம என்ன பண்றோம், ஹையர் சீக்வன்ஸ் நம்பர் உள்ள அப்டேட்டை அனுப்பி விடுறோம். புரிஞ்சுதா? இக்னோர் பண்றது எப்பன்னா, நம்ம சீக்வன்ஸ் நம்பரும் 5 வர்றதும் 5 அப்படின்னா அவன் தான் இக்னோர் பண்ணிடணும். நம்ம இன்னொருத்தன் 6ன்னு அனுப்புறான்னா அவன் என்ன பண்ணிக்கணும், ஆட் பண்ணிக்கணும். இன்னொருத்தன் 4ன்னு அனுப்புறான்னா அவனுக்கு என்ன சொல்லணும், ஏப்பா இரு, பொறுமையா இரு, உன்னோட நான் ஜாஸ்தி தெரிஞ்சு வச்சுன்னு இருக்கிறேன், நான் கொடுக்குற வச்சுக்கோ அப்படின்னு அவனுக்கு நம்ம அனுப்பணும். இல்லையா? 3 வகையான நெய்பர் பார்ப்போம். ஒருத்தன் நமக்கு மாதிரி ஈக்குவலா வச்சிருக்கிறான், இன்னொருத்தன் நம்மளோட அதிகமா தெரிஞ்சவன் அனுப்புறான், அவன் நம்ம வாங்கி வச்சுக்கணும். இன்னொருத்தர் நம்மளோட கம்மியா தெரிஞ்சுக்கிட்டு நமக்கு அப்டேட் அனுப்பிச்சிட்டு இருக்கிறான், அவனுக்கு சொல்லணும், இரு பொறு நான் உனக்கு தரேன் பாரு, என்கிட்ட பாரு நிறைய இருக்குது, ரொம்ப கம்மியா இருக்குது அப்படின்னு அவனுக்கு நம்ம கொடுத்து ஈக்குவல் பண்ணி விடணும். So it is based on the sequence number the database gets synchronized, updated. Any question from anyone? Okay, fine then. Right, so this chapter was giving us a lot of information. One more additional information. You see, hello packets are sent every 10 seconds. We learned the dead timer is 30 seconds. 30 or 40? 40 seconds. 30 or 40, no, 14 so 40 seconds is the dead time. Other than this, there is also a periodic update every half an hour. Don't forget. There is also a periodic update. மாற்றம் ஏற்படுதோ இல்லையோ 30 நொடிகளுக்கு ஒரு முறை தனக்கு உண்டான எல்லாவற்றையும் பிறருக்கு அனுப்பி வைச்சு சிங்க்ரனைஸா இருக்கிறோமான்றத ஒரு முறை கன்ஃபார்ம் பண்ணிக்க. OSPF மாற்றம் நடக்கும் பொழுது உடனடியா எல்லாருக்கும் அனுப்பும் அந்த மாற்றத்தை, அதுல எந்த மாற்றமும் கிடையாது. அதற்கும் மேலாக ஒவ்வொரு அரை மணிக்கு ஒரு முறை டேட்டா பேஸை மற்றவங்களுக்கு அனுப்பி பார்த்துக்கோப்பா, இல்லை ஒரே மாதிரி இருக்கிறோமா பார்த்துக்கோ, இல்லைன்னா நீ அப்டேட் பண்ணிக்கோ அப்படின்னு நம்ம அனுப்பி வைக்கிறோம். திஸ் இஸ் டு மேக் ஷுர் தட் எவ்ரி ஒன் இஸ் ஃபுல்லி சிங்க்ட். ரைட், ஸோ திஸ் சாப்டர் வாஸ் அபவுட் OSPF introduction, but it's a very good introduction, covered a lot of important aspects.